Yes. So use this equation first, this one. Okay. In order to find out P of B3 by A1. Okay. So P of B3 by A1 is nothing but P of Bj by AI. So this term is there. This is what we have to find out. This implies P of AI comma Bj divided by P of AI is equal to P of Bj by AI. Right? So this implies, so now just substitute for I and J. Okay, just substitute for I and J. So what is the value of I?
1.
Yeah, I value is 1. Why? Because we have to find out P of B3 by A1. So we have to find out P of B3 by A1. So hence I value is equal to 1. So then this will imply P of A1 comma, what about J value?
3.
3. So B3. So J value is 3. So P of A1 comma B3 divided by P of AI. I value is 1. Okay. This is what P of B3 by A1 equal to. So now what is P of A1 comma B3?
5 by 36.
Yes.
5 by 36.
5 by 36.
Yes, sir.
We shall check that here. So P of what is the value we want? A1 comma B3. So in this JPM, so it is where is P of A1 comma B3? First row, last term. Okay, first row, last term, P of A1 comma B3. What is the value? 5 by 36. Okay, 5 by 36. So P of, so by, or you can write it from given JPM, we have, so P of A1 comma B3 is equal to 5 by 36. Okay. So what about P of A1? Whether it is given P of A1?
No, sir.
Yeah, then how will you find out P of A1? You want P of A1. So you have to go for the next property of the JPM. What is that? So if you add the elements of the JPM row wise, you will get the probability of input symbols. Okay, so that is why I told you have to remember the properties. Otherwise, you will not be able to solve the problem. If you don't remember the properties, then it is very difficult. Okay, so if you take the sum of elements of the JPM row wise, then you will get the input symbol probabilities. So row wise you have to take the summation. So which probability we have to find out now? Which is the probability we have to find out? P of A1, correct? So in order to find out P of A1, so which row we have to take sum of which row elements? Sum of
First
which
row.
row elements? Yeah, first row elements. You have to take the sum of first row elements. Then you will get the probability of first input symbol, that is A1. Okay. So again you can write here from the property of JPM. Okay. Taking the sum of first row. Okay, we have. So what do we have? P of A1 is equal to what is the first row elements? It is P of A1 comma B1 plus P of A1 comma B2 plus P of A1 comma B3. Okay, or what is the property say? So can you tell me the generalized property? Generalized property summation P of AI comma Bj is equal to P of AI. Okay, so what is the range of J? J is equal to 1 to
3.
yes. So it is J is equal to 1 to S, which is equal to 3 for this example. Okay, so just substitute for I is equal to 1 for first row. Okay, I is equal to 1 for the first row. So then this implies summation J is equal to 1 to S, which is equal to 3. P of A1 comma Bj is equal to P of A1. So now just substitute for J terms. So J is equal to 1 means it is P of A1 comma B1 plus J is equal to 2 means P of A1 comma B2 plus J is equal to 3 means P of A1 comma B3 is equal to P of A1. Okay. Yeah, now what is the value of P of A1 comma B1? See the JPM P1 comma A1. Sorry, P of A1 comma B1.
1 by 12.
1 by 12.
It is 1 by 12. So 1 by 12. Next, P of A1 comma B2, it was star actually. Okay, it was unknown value, but we found out that. Okay, A1 comma B2. How much is that? 1 by
9.
9. So it is 1 by 9. So just write down that 1 by 9 plus. What about P of A1 comma B3?
5 by 36.
5 by 36.
So it is given as 5 by 36 in the JPM is equal to P of A1. So just add this and tell me what is the value of P of A1.
1 by 3. 1 by 3, sir.
1 by 3. Okay, highlight your findings, okay, so that it is easy for the examiner to evaluate the scripts. Yeah, so next. So we'll use this formula now. So P of B3 by A1 is equal to. Now what about P of A1 comma B3? Joint probability of A1 comma B3, it is 5 by 36 divided by P of A1, we just found out. What is that?
1 by 3.
1 by 3. So this implies, so what you will get for P of B3 by A1? How much you will get? 5 by?
5 by 12.
5 by 12. So this is P of B3 by A1. Okay, any doubts here? Fine. So now, next we have to find out what is the value. Next value is P of, next value we have to find out P of A1 by B3.
Comma B2.
Not comma, P of A1 by B3. First we found out P of B3 by A1. This is output conditional probability. Okay, output conditional probability. So next is input conditional probability. P of A1 by B3. Input conditional probability. So how will you find out P of A1 by B3? Again, you have to use the same formula, this one. Okay, for joint probability. But now you have to use which one? You have to use these terms because you want the input conditional probability. Okay, so you have to use this. So this will imply, so joint probability is given by, yeah, so P of AI comma Bj is equal to, so in terms of input conditional probability, it is P of AI by Bj into P of Bj. Okay, so now since I want P of AI by Bj, so this implies P of AI by Bj is equal to P of AI comma Bj divided by P of Bj. Okay, so now we already so now we have to substitute the I and J terms. So since we want P of A1 by B3, It is P of A1 by B3. Okay. So what is the value of I then? I is equal to 1. Okay, and J is equal to 3. So P of A1 comma B3 divided by P of, so J is equal to 3 means P of B3. Okay. So we already know P of A1 by B3. Okay, and we already know P of B3 also. We have found out that. So just substitute the values. So P of A1 comma B3, what is the value? 5 by
5 by
36, correct. Divided by P of B3, probability of the output symbol B3. We have found out that. If you remember, it is 5 by 18.
18.
Yeah, it is 5 by 18. 5 by 18. So this implies
1 by
P of
12.
A1 by B3 is equal to 1 by 2. Okay, so any doubts here? So this is the answer for the second sub question. Fine. Any doubts?
No, sir.
Okay, so next, third sub question is, are the events A1 and B1 statistically independent? So are they statistically independent and why? Okay, so when such question is asked whether they are statistically independent or not, you have to verify this particular relationship. So what is that is? So this is the answer for the third sub question. So in order to find out whether they are statistically independent, so you have to find out this. P of A1 comma B1 is equal to P of A1 into P of B1. I'll write it once again. So in order to say that the events A1 and B1 are statistically independent, it has to satisfy this property. The joint probability of A1 with B1 should be equal to P of A1 into P of B1. Okay. So whether this is true, let's see. So what is P of A1 comma B1? Use the JPM and tell me. P of A1 comma B1, what is the value? JPM ಏನಿದೆ value? Am I audible at least?
1 by
Yes.
12.
1 by 12, sir.
Okay. 1 by 12. Let's see whether it is equal to P of A1 into B1. So what is P of A1? We found out 1 by 3 into P of B1. P of B1 is given.
1 by 3, sir.
It is also 1 by 3. Okay. So obviously it is not equal. Okay. So it is 1 by 12 not equal to 1 by 9. So since this condition, this property is not, it is not being satisfied. Okay. So you can say that the events A1 and B1 are not statistically independent. Okay, are not statistically independent. And so if this condition was true, okay, then you can say that A1 and B1 are statistically independent. Since it is not true, so they are not statistically independent. So this is the answer for the third sub question. Okay, so you have to write the conclusion like this. You have to write the conclusion. Yeah. So any doubts here? Any doubts overall? Any doubts overall? See, at least I want a yes or a no.
No, sir. No, sir. No, sir.
Okay. See, such type of problems will be asked for 6 to 8 marks. Okay, and they will be solvable only if you remember the properties. Okay, if you don't remember the properties, then you can't do anything. Okay, that is why I'm stressing. Remember the properties of the JPM. Okay, remember the formulas and also remember the property of the channel matrix. Channel matrix. Okay, can anyone tell me the property of channel matrix? It has one property. Channel matrix. What is the property of channel matrix? No one remembers? At least go through whatever you have written and tell me what is the property of channel matrix.
Sum of all the
Sum of
elements in any row of the
in a
channel
row.
matrix is equals to unity.
Okay, so if you take the sum of elements of any row or column wise, sum of elements in column wise of a channel matrix, you will get unity. Correct? You will get unity. So how to represent that property? Can anyone tell me the formula for that? Can anyone tell me the formula for that?
J equal to 1 to S. P of
Property.
Bj
Yeah,
by
1 minute.
AI equals to
1
1.
minute. 1 minute. Property of channel matrix. Property of channel matrix. So what is the property? If you take the sum of elements row wise, it will result to unity. Okay, you can write the property in your own words, but remember the property. So what is the formula? Summation
I is equals to 1 to R. P of AI is equals to 1.
is it I is equal to or J is equal to?
Equal to, sir. J is equal to 1 to S. P of Bj by Ay is equal to 1.
Yeah, so it is J is equal to 1 to S because you are taking the sum of the elements in a row. So whenever it is sum of elements in a row, so J will vary, not I, because I is common for that particular row. Okay, so remember, whenever you take the sum of elements row wise, J will vary, not I. So P of Bj by Ai is equal to 1. Okay, this is the property of channel matrix. So now we will list down the property of JPM. See, these formulas are very important. You have to write it down somewhere and you have to visualize this every day so that you will remember them. Okay, property of JPM. Yeah, can you tell me the first property? The sum of elements.
The JPM along the column.
Yeah, column wise. So what is the formula? Summation I is equal to 1 to R. See, since you are taking the elements column wise, so J will not vary, only I will vary. Okay. So I is equal to 1 to R. P of AI comma Bj is equal to, tell me what is equal to P of
Bj.
Yeah, output symbol probabilities. If you take the sum of elements column wise of a JPM, you'll get the output symbol probabilities. Okay, so this, see, many are finding it difficult to remember this because you have not gone through the formulas properly. Okay. Next, second property is, so sum of elements row wise. Okay, so then it is summation. Since it is row wise, I will be common. So J is equal to 1 to S. P of AI comma Bj is equal to what you will get is equal to P of
AI.
Yeah, I don't think you people have properly waken up. Okay, no one is willing to answer. See, from this point onwards, so there will be many formulas you have to remember. Okay, so if you don't remember the properties formulas, definitely you will not get through this subject. Okay, remember this. This subject is good for both scoring as well as failing also. Remember that. See, I'm not. You can say. Telling negative about the subject, but it is a fact. Okay, you can score out of what also in this subject. It is very easy, and it is very easy to fail also. Okay, so unless you remember the formulas properties, you cannot do anything. Next, property 3. So it is sum of all elements of JPM.
Unity.
Yeah, so sum of all elements of JPM. So how will you write that? Summation I is equal to 1 to R.
1 to R. J equal to 1 to R.
J is equal to 1 to S. P of
P of
AI comma Bj is equal to 1. So these are the very important properties that will help you to solve the problems related on channels, channel matrix, joint probability matrix. Okay. So unless you remember these formulas, it is very difficult. As I told, write down these formulas somewhere. Okay. So that you will remember them whenever it is required. Go through them daily so that it is very easy to remember, because there are both terms here in the formulas and in the matrices. Okay, there are input conditional probabilities as well as output conditional probabilities. So you don't get confused where to write input conditional probability and where to write output conditional probability. Okay. Yeah, so we will continue and we shall see whether we got the same thing. Yeah, so we got 1/2 here, and we got that they are not statistically independent. Okay. Yeah, entropy functions and equivocation. So next topic is entropy functions and equivocation. So there are various types of entropies here. Whenever we talk about channels, okay, there are various types of entropies. So the first type of entropy, okay, the first type of entropy is known as priori entropy. Priori entropy. Okay, so we shall see the definition for this priori entropy. So the entropy of the input symbols A1, A2, A3 up to AR before their transmission is defined as priori entropy, denoted by capital H of A. Okay, capital H of A. So what is priori entropy? It is the entropy of the input symbols before transmission. Before transmission. So let's say there is a channel here. This is the channel. So at the transmitter side, there will be a source which will be transmitting the symbols. And how many symbols are there? So there are symbols A1, A2, A3 up to AR. So these many symbols will be there at the transmitting side. Okay. So priori entropy concerns, or it is related to the transmitting side or the transmitter. So, and it is nothing but the entropy of the input symbols. Okay, entropy of input symbols, which is also denoted as a capital H of A. Okay, so capital H of A. So can anyone tell me the formula for entropy that we have already studied in module 1? Entropy of a source which emits R symbols. Yes?
Summation I is equals to 1 to Q.
Yeah, so summation I is equal to 1 to Q. Okay, that is the formula. I is equal to 1 to Q. But here there is no Q, but the number of input symbols is equal to R. Okay, so hence it is I is equal to 1 to R. Okay, P of AI into
Log 1 by
log 1 by P of AI to the base 2. Okay, and unit is
bits
bits
symbol.
per symbol. So this formula we already know. Same formula we will apply here, but instead of Q symbols, it is R symbols at the transmitter end. Fine, any doubts here? This is known as priori entropy. Before transmission, what is the entropy? Next entropy is known as posteriori entropy. Posteriori entropy, which is also known as conditional entropy. So what is this? Let's see. The entropy of the input symbols A1, A2 up to AR. This is after transmission and reception of a particular output symbol Bj. Okay, so what is posteriori entropy? So once you transmit the symbols A1, A2 up to AR, okay, and you receive one of the output symbols Bj, okay, one of the output symbols Bj. So the entropy is known as posteriori entropy. So it is defined as posteriori entropy, or which is also known as conditional entropy. Okay, so how it is denoted? It is denoted as H of AI by Bj. Okay, H of AI by Bj. This is posteriori entropy. So remember, this entropy, as the name itself indicates, posteriori means after transmitting these symbols. Okay, after transmitting these symbols, once you receive a particular output symbol Bj, okay, so what is the information conveyed? So that is what is posteriori entropy, which is denoted as H of A by Bj. Okay, so let's see what is the formula for this. H of A by Bj is equal to, so I is equal to 1 to R, since you are transmitting R number of input symbols. It is P of AI by Bj. So what is AI by Bj? What type of conditional entropy is this? What type of conditional entropy is this? P of AI by Bj.
Input.
Yeah, it is input conditional probability. P of AI by Bj into log 1 by P of AI by Bj bits per symbol. Okay, so this will be equal to summation I is equal to 1 to R. So we have to consider the input conditional probabilities P of AI by Bj into log 1 by P of AI by Bj. So it is bits per symbol. So this is after transmitting the input symbols and reception of any one output symbol Bj. Okay, that is what is posterior entropy. So next, third entropy is equivocation. Okay, so what is this equivocation? It is defined as average value of all conditional entropies specified in the above equation when J is varied from 1 to S. Okay, so equivocation is nothing but it is the average value of this conditional entropy that we have found out, or posteriori entropy. You have to take the average of this, then whatever the value resulting, that is known as equivocation. Okay, so what do you mean by taking average? Taking average means here we have considered only for one output symbol Bj. Okay, only for one output symbol Bj. If you consider all the output symbols, okay, then that is the average. Fine. So that is what is equivocation. This is the third type of entropy. Equivocation. Okay. So this equivocation is denoted as capital H of A by B. So here the notation. So posteriori entropy is H of A by Bj. Why? Because you are considering only one output symbol. That is why it is specified as Bj. But now, since you are considering all the output symbols, so it is capital A by capital B. So B represents, capital B represent all the output symbols. Okay. So this will be equal to, as I told, you have to consider all the output symbols. So then only it is the average. So what is that? So to consider all the output symbol, you have to multiply H of A by Bj into Bj, and you have to vary J from 1 to S, since you are considering all the output symbols. Okay, since you are considering all the output symbols. So write on that. So H of A by B is equal to summation J is equal to 1 to S, so that you will consider all the output symbols. Okay, into the conditional entropy or the posteriori entropy H of A by Bj. This will be equal to summation J is equal to 1 to S P of Bj to just substitute the value for H of A by Bj. So what is that? What is H of A by Bj? Summation
J
I is equal to 1 to R. This formula I have to substitute, that's all. I is equal to 1 to R P of AI by Bj, P of AI by Bj into log 1 by P of AI by Bj. Okay. So this will be equal to, so take the summation outside. So J is equal to 1, I is equal to 1 to R into summation J is equal to 1 to S. Okay. So it is P of AI into Bj into P of Bj into log 1 divided by P of AI by Bj. Okay. Yeah. Next, what do you have to do? So what is this term? These two terms? P of AI by Bj into P of Bj.
P of AI comma Bj.
It is the joint probability of AI with Bj. Correct? Any doubts here? Any doubts? So this will be equal to joint probability of AI comma Bj into log 1 divided by P of AI by Bj. So what is the unit? Bits per symbol. This is, since it is the entropy, it's bits per symbol. So this is H of A by B. Okay. So what you can do is, you can give individual numbers for the equations. Okay. You can call this as equation. What is the number we have stopped? I think 8 or 9 previously.
9, sir.
9. Okay. So you can call this as 10. Okay. So that you can remember the equation. That's all. Okay. You can give any number, no problem, but remember the equations properly. That's all. So this is 11. Okay. Posteriori entropy, or which is also known as conditional entropy. And this is 12. Fine. Any doubts here? So now what we'll do is, we'll interchange A and B in this equation. Interchange A and B in 12. So what we'll get? So it is H of B by A. Okay, instead of A it is B, and instead of B it is A. So summation So the summations will also change now. So j is equal to 1 to s. Instead of I is equal to 1 to r, since you are replacing a with b, so the range of a will be replaced with the range of b. J is equal to 1 to s. Okay. And then the range of b will be replaced by range of a, which is I is equal to 1 to r. Okay. So then this is p of bj comma ai into log 1 divided by p of bj by ai, just replacing ai with bj. Sorry. Okay, so a and b interchanging them. So then, so rearrange these summations again. So I'll write I is equal to 1 to r first, and then j is equal to 1 to s. Okay. Then this term p of bj comma ai. See, there is a relationship with the joint probability of ai with bj. Okay, so the joint probability of ai with bj will be same as joint probability of bj with ai. Okay, so this is a property of JPM. Fine, remember this. Joint probability of ai with bj is same as joint probability of bj with ai. So hence this term here, joint probability of bj with ai is same as joint probability of ai with bj. Okay, into log 1 divided by p of bj by ai. So you can call this as, so write down the units, bits per symbol. So you can call this as equation number 30. So this is h of b by a. Okay. So h of a by b. So what we'll use in h of a by b is we'll use the input conditional probabilities. Okay. If we input conditional probabilities are not known, so then you can use the output conditional probabilities to find out h of b by a. Okay. H of b by a is also known as equivocation only. Fine. So now what is this equivocation is? So if you come to the channel here, so this equivocation h of a by b, okay, is nothing but it is the amount of information lost due to noise in the channel. Okay, so that is what is h of a by b or equivocation. So equivocation is nothing but amount of information lost in the channel due to noise. Fine. So h of a is the amount of information you are inputting or transmitting. H of a by b is the amount of information lost in the channel. Okay. So then what is the amount of information that will be received then? Can anyone tell me? See, if you are transmitting h of a amount of information to the channel and h of a by b information is lost in the channel, what is the remaining information that you will receive?
Minus h of a by b.
It is h of a minus h of a by b. This is the amount of information transmitted. This is the amount of information lost. Then you take this, if you subtract h of a by b from h of a, that is the remaining information that will be received at the receiver end. Okay. Yeah. So that information that is received at the receiver, it is known as mutual information. Mutual information. Okay, so we shall see what is mutual information. So mutual information, when an average information of h of a is transmitted over the channel, okay, an average amount of information equal to equivocation, which is h of a by b, is lost in the channel. due to inter-symbol conversion, which is also known as due to noise. Okay, which is due to noise. So you are transmitting h of a amount of information, average information, and h of a by b amount of average information is lost in the channel. So the remaining information received at the receiver with respect to an observed output symbol is called as mutual information. Okay, which is given by h of a minus h of a by b is equal to I of a comma b. Okay, so this mutual information is represented as I of a comma b. This is what is the mutual information. When any doubts here, the amount of information received is known as mutual information. So the formula for this is I of a comma b is equal to. Can you tell me? I of a comma b equal to
h of a minus
yeah
h
minus
of a minus of a by b.
h of a by b. Okay. So now we'll find out a formula for h of a comma b. Sorry, I of a comma b mutual information by solving this equation. So h of a. So just substitute the equation for h of a. Can you tell me? It is I is equal to 1 to the formula for h of a. Priori entropy. I is equal to 1 to r p of ai into log 1 by p of ai. Okay, so this is priori entropy minus minus it is summation I is equal to 1 to r summation j is equal to 1 to s p of ai comma bj so log 1 divided by p of ai by bj. Okay, so these are the formulas. Fine. So next thing what we'll do is in order to solve these two, okay, so what we have to do is here in the first term there is only one summation, okay, but in the second term there are two summations. So in order to solve this, so both the terms should have two summations. So it is easy to simplify. So how will you add one more summation to this particular term, to the first term? So I is equal to 1 to r is already there. You have to add j is equal to 1 to s to this term. If you add this summation, also the total value of the term should not change. It should not alter. How will you add that?
Multiply and divided by p of bj.
No, multiply and divide will not solve the problem. I need to add a summation, which is j is equal to 1 to s. Even though you add it, the total value of the term should not change.
Is equal to 0.
So you have to use the property of channel matrix here. Can anyone tell me the property of channel matrix? Can anyone tell me the property of channel matrix? Just 10 minutes, 20 minutes back we discussed.
Summation of from j is equal to 1 to s p of bj by ai is equal to 1.
1. That is, if you take the sum of elements of the channel matrix row wise, you will get 1. And what is the formula for that? The summation j is equal to 1 to s p of bj by ai equal to 1. So even though you introduce this term in this first term here, okay, what is the total value of this term? It is equal to 1 only. So if you are actually multiplying it by 1, okay, so which will not change the overall term, the value of the term. Fine. So what I'll do is I'll introduce this term. Summation I is equal to 1 to r p of ai into log 1 by p of ai. This term I'll multiply with j is equal to 1 to s P of Bj by Ai. So actually this term is equal to 1. Okay. So we are multiplying this entire term with 1, which will not change its value. Fine. So the next term will be as it is, minus summation I is equal to 1 to R, summation J is equal to 1 to S, P of Ai comma Bj to log 1 by P of Ai by Bj. Okay. This implies so I is equal to 1 to R. Okay. Then I'll take this summation. J is equal to 1 to S. Okay. So it is P of Ai into, so I'll take this term P of Bj by Ai. Okay. Into log 1 by P of Ai minus this term as it is. No change in this term. Okay. Second term as it is. You have to write down this term. Okay, don't write like this. Write down the entire term. Yeah, next. So what is this term here? P of Ai into P of Bj by Ai.
P of Bj.
No. I is equal to 1 to R.
P of AI comma Bj.
Yeah, so it is the joint probability of Ai with Bj. So it is P of Ai comma Bj. Okay, into log 1 by P of Ai minus, so the second term, the summation I is equal to 1 to R, summation J is equal to 1 to S, P of Ai comma Bj into log 1 by P of Ai by Bj. What is common in these two terms?
P of Ai comma Bj.
Actually common is summation I is equal to 1 to R, summation J is equal to 1 to S, P of Ai comma Bj. This is the common term into is log 1 by P of Ai. This is the remaining term in the first term minus, what is the remaining term in the second term? Log 1 by P of Ai by Bj. Okay, any doubts till now? Any doubts? Okay, so we'll continue this derivation in the next class. Okay, we have to still continue, we have to further simplify this. So remember till this point, we'll continue from the next class. So I'll download the attendance.